The steel rule. This engine existed in imagination only before it was put on paper in the form of drawings. These drawings guided the men in the forge, where great hammers pounded blocks of steel into shape, and men in the machine shop followed these drawings to work the rough forgings to exact size. Every part of every machine, large and small, is checked with measuring tools at every step in the work to make certain that the size and shape of each part matches the dimensions on the drawing exactly. Dimensions are always measurements of distance, such as length and such as width, which includes diameters, and such as the depth of slots and of holes. The radius of a fillet, the throw of a cam or an eccentric, is a measurement of distance. Also, the pitch of a screw, the distance between threads, is a measurement of distance. To measure distances, the machine operator has measuring tools with precise scales, usually divided in terms of a standard unit of length. This standard unit of length or distance in the United States is the inch, and this must be exactly the same on all measuring tools. The degree of precision to which a part must be made is specified on every shop drawing. Here will be found definite information as to size, shape, and location. Dimensions given in fractions ordinarily are measured with a rule, since the graduations on the scale are capable of measuring within the tolerances allowed. A dimension given in decimals with closer tolerances requires a more precise tool, such as a micrometer. These two tools are the most widely used in any shop for measuring distance. The chief difference between the two is the accuracy with which distance can be measured. The steel rule measures in fractions of an inch to 1/64th. One 1/64th of an inch is nearly 16 1/1000ths of an inch, written in decimal form as 0.015625. Measuring in distances as small as 1/1000th of an inch or less is done with the micrometer caliper. Many other tools have been devised to attain precise and delicate measurements. Some of them are highly specialized, but the most commonly used measuring tool is the steel rule. The steel rule usually has 4 scales, 2 scales on each side. This one graduated in 1/8ths of an inch, and this scale in 1/16ths of an inch. The scales on the other side are graduated in 32nds and 64ths of an inch. Some rules have numbered graduations. These make the scales easier to read and reduce the possibility of errors. Rules are also made with other standard systems of graduations. Here is a scale graduated in 10ths, 20ths, 50ths, and 100ths of an inch. Then there are scales graduated in 12ths, 24ths, and 48ths, and others in 14ths and 28ths, and other systems of graduation. Before using a steel rule, check the scale identification for the system of graduation to avoid errors. The rule should always be held parallel with the edge of the piece. It is good practice to set the 1-inch index to the end of the piece. Subtract the value of the first inch on the rule. The reading is 3 inches minus 1 inch. The piece is 2 inches wide. When measuring the length of a piece of round stock, be sure to hold the rule straight with the center line. To measure the diameter of a round piece, place the rule directly across the center. A narrow, flexible rule is particularly useful where the rigid rule will not go because of obstructions. To measure the diameter of a hole, be sure the rule is directly across the center. The end of the rule should bear against the side of the hole, and the rule should be tilted as little as possible. There are many types and variations of steel rules. Among them is the hook rule. It is particularly convenient to use for measuring narrow widths, as from a shoulder. Steel rules are made in very short lengths mounted in holders, and are especially useful for taking measurements in close places. One modification of the steel rule is in the form of a depth gauge useful for measuring slots and holes. Be sure the depth rule is held at right angles to the face of the work. Lock the clamping screw. The narrow rule will enter holes down to 3/16 of an inch in diameter. The rule depth gauge is convenient to use in measuring the depth of keyways. Another application of the steel rule is in the combination square. Among its many other functions, the combination square is used in laying out work. If the material is of steel, a solution may be used to make layout lines more easily visible. Using a rag that is free of oil or grease, swab the work sparingly with the solution. A drawing shows a plate in which 2 holes are to be drilled. One hole is to be 3½ inches from one edge and 3½ inches from the other edge. The second hole is to be 4 inches from the first hole and 4½ inches from the edge. The rule is set for the center lines for the first hole, 3½ inches from the edge as specified by the drawing. A scriber is selected. Holding the head of the combination square against the work, scribe the line along the end of the rule. The groove in the rule should be on top, otherwise the scriber may make a nick in the line. The center line for the first hole is to be 3½ inches from this edge. The combination square need not be adjusted for this dimension, being already set on the 3½ inch index. According to the drawing, the second hole should be 4 inches from the first. Set the rule 4 inches more to the 7½ inch index. According to the blueprint, the center of the second hole is to be 4½ inches from this edge. Set the rule to the 4½ inch graduation on the scale. The juncture of the lines is nicked with a center punch. Use a magnifying glass. It assures accurate centering of the punch. A light tap is all that's required. A heavy blow may shift the punch. In this particular case, it is required that the holes be scribed on the work. A divider is used for this purpose. In setting a divider to a dimension on the rule, locate one point in one of the inch graduations and adjust the nut so that the other point falls into the correct graduation. Some men prefer another method of holding the dividers for setting. Either way is correct. Select the method which seems most convenient. The divider points should be sharp. If they are dull or bent, it is impossible to obtain an accurate setting. Set one leg of the divider in the center punch mark. Scribe the circles. For laying out large dimensions, another form of divider, the trammel, is used. It consists of a bar and 2 points, one or both of which are adjustable. A commonly employed tool for transferring measurements and for checking outside dimensions is the outside caliper. To set an outside caliper, one leg should be held firmly against the end of the rule and the other leg adjusted to the proper dimension. Be sure to set it so that the point comes to the center of the graduation. If the outside caliper has to be brought from a wide setting to a small one, less wear of the adjusting screw and nut will result if the 2 legs are pinched together. The nut will turn freely and an easier and quicker adjustment will result. The outside caliper is often used to check work on a lathe. The operator uses care not to force the caliper, which would be sure to result in a false measurement. Outside calipers are frequently used to determine a measurement by transferring the calipers from the work to a rule. The companion tool to the outside caliper is the inside caliper, which is used for taking inside measurements and for checking internal dimensions during production. To set the inside caliper, put the end of the rule and one leg of the caliper against a solid surface. Adjust the other leg to the desired distance. Set it to the center of the graduation. Inside calipers are used chiefly to check diameters of holes. The right feel as the points drag slightly tells the operator whether the caliper fits the hole properly. Steel rules and their various modifications and the measuring instruments with which they are employed find wide use in the machine shop and layout department. The usefulness of any tool, even though it's only a simple instrument like a steel rule, is maintained by good care. Well-oiled tools kept in good order